We're on to Istvan Nagy Korodi, Reservoir Geologist from MOL, and he's going to be talking about the colours of hydrogen before we go on to the final panel of the day. So over to you, Istvan.
Dear ladies and gentlemen, good afternoon. My name is Istvan Nagy. I'm a reservoir geologist working for MOL, and I'm really glad to be here. And I'm going to give a short introduction about the colors of hydrogen, exploration, production, market trends, and future outlook. First of all, we have to mention disclaimer. Everything what I'm telling right now is not representing the company's ideas or any kind of relationship with the company. I'm just talking about my own ideas and what I think is important to mention in the hydrogen board. What we are going to talk about. So we are, first of all, the presentation is not intended to give you an exhaustive list of opportunities, and it should be considered as an insight. And we will have a short intro. Instead of an intro, I'm going to talk about the periodic table just a little bit. Then we will continue with the colors of hydrogen, about current and emerging hydrogen production technologies. We will touch the hydrogen markets, the key trends driving its adoption, and we will talk about hydrogen outlook at the end, what the future actually holds for the hydrogen in the energy mix as a snapshot. Prior changing the slide, I'm going to start or continue with a short story. It was very funny for me when I was discussing the idea of hydrogen exploration with one of my bosses a couple of years back. We were debating about what's the most important, because being an oil and gas professional, especially you as downstream representatives, it's important for us that we are producing a lot of oil and we are producing a lot of chemicals. So the most important substance for us is the oil and gas. So we are very proud of it, and it was hard to convince my boss that why should we look for hydrogen, because the crude oil is just the most marvelous substance on the universe. So if you think about the energy content of crude oil, it's very hard to debate with. However, it could hold about 45 megajoules of energy. But if you think about the energy content as weight, not as volume of hydrogen, 1 kilogram of hydrogen holds actually about 2.5, 3 times more energy. So it's a good idea to look at hydrogen as a very good option. And obviously we are using it in the downstream, but for the energy transition, it's a viable solution, I would say. And we should deal with hydrogen from a very different point of view as a very good idea to deal with. So instead of an intro, the periodic table and the criticality of hydrogen, you can see different colors and different elements on this periodic table. And top left corner, you can see the hydrogen is just white, so it's not really critical. But if we think about its usage, and we are going to talk about, and during the day we already listened several discussions and ideas about on its importance, is very self-evident. Just I wanted to show this periodic table because there are other elements which are considered even more important, which are related to energy transition. And I'm not an investor, but if you are looking at this table, obviously you can see some red colors. Depending on the calculations, there are only a couple of years remaining until the depletion of these known reserves. We are not running out from hydrogen. However, we should have very good technologies to capture it, because despite of the fact that hydrogen is the most abundant element in the known universe, it constitutes about 75% of it, it's very hard to find in a huge quantities. Generally, you can find it in a compound. When Henry Cavendish discovered it, it was hard to give a name for it, but during the reactions, he first thought that he discovered the so-called phlogiston, but at the end he realized that hydrogen, during its combustion, it just released water. So the name came from gen, like generation or creator, and hydro, like water. So this is how it actually happened. There are some thoughts that even Boyle encountered hydrogen before during his tests with metals, but obviously the history, due to the merits of Cavendish reactions, declares that Henry Cavendish discovered the element and named it as hydrogen. There are several different colors we need to mention. You might ask the question, why do we have so many colors? Because the hydrogen actually is a colorless gas. So that's a pretty fair question, to be honest. And when I first met with this kind of rainbow, I was shocked as well. And I'm just trying to give you some insight into these colors. So there are multiple colors, and I'm pretty sure that other type of colors will pop up in the near future as well, because everything is easier and is handled in the hydrogen world based on the energy used for this hydrogen production and how the hydrogen actually produced. So nowadays we can say that most of the hydrogen is produced as gray hydrogen, which is extracted from natural gas through steam methane reforming. This is the most common nowadays, producing roughly about 97% of hydrogen. There are other colors like blue hydrogen, which is produced from fossil fuels, and the CO2 during this production is captured or pumped back into the reservoir. Another type of hydrogen which is relevant is the green hydrogen, which is produced by electrolysis of water. As you could see in the previous slide, the first electrolysis was done in 1888, so this is a pretty old technology and it's pretty useful. However, it has got some problems as all the technologies. And there are others as like pink or purple when the energy comes from nuclear resources or nuclear power plants, and turquoise as well when the hydrogen produced by the thermal splitting of methane, and solid carbon is produced as well. The biggest carbon footprint belongs to the brown or black hydrogen, and the hydrogen extracted when the hydrogen is extracted from coal using gasification. There are others like yellow hydrogen is pretty similar to the green, but the electricity could come from fossil fuels as well. The latest or the newest versions are like aqua hydrogen, and the hydrogen produced by placing oxygen into a sealed fuel deposit between grains of rock using unswept crude oil. There are some interesting experiments in Northern America. Another type of hydrogen is called like gold hydrogen, when bacteria are used to release hydrogen. And this could be considered as an enhanced oil recovery method, because during the bacteria's process, not only the hydrogen released, but the bacteria are cutting the longer organic molecules into shorter one, and they are producing an extra oil as well. So this is really interesting for exploration and production purposes. And last but not least, the white hydrogen, which is produced as a byproduct of industrial processes, and is also referred as to the natural hydrogen, which is found in the reservoirs, but it's very rare to find those hydrogen types. One country in Mali is one country in the world. Mali is a country like that. So there are other aspirations ongoing for white hydrogen in Australia, for example, as well, and in Europe as well. So we already learned about the colors of the hydrogen. The economics behind are very, very different, and the emission of CO2, as you already mentioned. The most expensive is the green hydrogen, sometimes ranging from a couple of US dollars to 9 or 10 or even 30 US dollars per kilogram. And most cheaper is the gray hydrogen what we are using right now. So we have to do something with the price of the green hydrogen, because nowadays it's like it acts like, or this process is like um, the most environmental friendly. However, speaking of economics, is like burning money. So about um, 90% of the money, or about 70% of the money generated, like electricity, and is wasted during the process. So this is something what we have to consider later on. Hydrogen markets, there are different goals, and governments and industries are focusing on reducing emissions. There are policy incentives, as you can see here. I'm just referring to the European Union new policies, the Fit for 55 package, which actually tells that zero tailpipe CO2 emissions from 2035, and about 23% of procured fleet must be zero emission, as for the Clean Vehicles Directive. There are pretty similar requirements for buses, 45% of emission reduction by 2030 and 90% by 2040 compared to 2019 emissions. And over half of it of the procured fleet must be zero emission. And pretty much the same stands for heavyweight duty vehicles and lightweights as well. We are working towards it, but as you know, the European Union regulation is there, but we are a little bit back with its implementation. So the alternative fuel infrastructure regulation requests us that one hydrogen refueling station should be in place at every 200 kilometers with 700 bar dispenser. So this is something what we are aiming for, and hopefully we will reach later. Other ideas, the technological advancements, there should be rapid improvements in electrolyzers and hydrogen storage. Here you can see the production with the electrolysis, and there are two ways. Either the hydrogen is transformed to synthetic fuels and green ammonia, which is happening now. So that's the most effective way of so-called way of hydrogen transportation, and then you can store it, and you can use for shipping to deliver it to the end use, which could be either steel industry, chemical industry, refineries, and shipping, and cars, and everything else. What is important to mention that we should grow in the infrastructure of hydrogen. So in 2022, as you can see on the map in the left, there is only a small amount of piping in the western part of Europe, and until 2030, this piping system is focusing on in Western Europe, and hopefully this will change according to 2040 plans, where the growth in pipelines and refueling stations will be so much bigger. There are some ideas to use the previous crude oil related pipelines for hydrogen transportation as well. We can think about the hydrogen brittleness and so on. Hopefully, this will be sorted out in the upcoming years. And about the hydrogen outlook, so how can we fuel the net zero future? On the right side of this slide, you can see the global hydrogen capacity targets by end use. As you can see, in 2022, there were 95 million tons of hydrogen produced, and it was used by industry and refining, so in downstream. There is a saying in downstream that there is not enough hydrogen, what we could not use for our refining processes. So this actually gives a very good hint on exploration related ideas that we need to look for natural hydrogen, for white hydrogen. But what I really wanted to say with this slide is that we are aiming for 430 million tons of hydrogen by 2050. And all this hydrogen should come online pretty soon by 2030, because it's required by power generation, because it is required by transportation. And as you can see on the bottom left corner of this slide, there is only half of the capacity in place for 2050 to reach this target of 430 million tons of hydrogen. So there are obviously questions how we can reach this, but obviously we have to work towards this target. And last but not least, as conclusions, there are some key drivers. The cost reduction, the technological maturity, and the policy support should be addressed. And obviously there are some challenges, as I mentioned before. The economic viability, the gray hydrogen is so much cheaper than green hydrogen. So we should deal with this, and we should find a solution. And the infrastructure gaps are there, so hydrogen fueling stations should be set along the highways, and everything should be aiming to enable these targets set by different governments and EU regulations. And obviously the market development should follow up these trends as well. And with that, I will thank you for your attention.
Thank you, Istvan. I do enjoy a presentation that talks about the colours of hydrogen. I think it's always good to get a bit of an education on this, considering I think a lot of people don't know the ins and outs of blue, green, white, pink, grey hydrogen, and it's really good to break it down. So thank you very much for this. Great presentation.